Welcome you all in my channel Chemistry the Mystery of Molecule. So today's topic is industrial production of hydrogen and its uses from the basic concept point of view. So let's start. So in this way you can see that first of all the importance of hydrogen. Why should we focus on hydrogen? This is because this is considered as fuel for future, and this tagline is given because of its maximum energy density, means energy output after its burning with respect to per kilogram, means how much energy you are getting, and this is maximum, even it more than lithium ion battery. So due to its lightweight, because we know that hydrogen is the lightest element in the periodic table, so that's why huge amount of hydrogen is there. And another thing, hydrogen is not that much stable molecule, but after burning it produces water which is very stable. That's why this energy output is too high. Second thing, it is ultimate stable reducing agent, means you may consider the safest or greenest reducing agent hydrogen, and source of different important chemical is hydrogen, such that like ammonia, vegetable oil. If we look at the example of ammonia, in presence of hydrogen plus nitrogen produces this ammonia molecule, and this ammonia molecule reacts with carbon dioxide to produce this urea. Okay, we know that urea is the most widely used synthetic fertilizer, and interesting point is that today existing 50%, almost 50% population is because of this one reaction, that is this Haber process, and followed by this urea synthesis. This artificial urea contribute feeding 50% of current global population. I have already discussed previously. Now, not only that, hydrogen itself along with carbon monoxide, it is useful for methanol production. Methanol means the simplest alcohol. Student, it's another very important potential fuel which will come later on. So this is used for methanol food production, and this is, you may consider this could be a substitute for gasoline, means the fossil fuel or petroleum. Okay, so okay, fine. Now if we focus little deeply, the oxidation state and the abundance of the precursor. Actually hydrogen could have possible three oxidation state possible for hydrogen: +1, -1 and 0. 0 is for hydrogen gas. Okay, so that's a thing that generally in lower atmosphere doesn't exist. Mainly you will find two kind of oxidation state, that is +1 and -1. And if you look at the +1 oxidation state, which is relatively stable, because somehow hydrogen is considered like, I say like, group 1 metal, means it prefers to give one electron and produce this +1 oxidation state, and produces one of the most stable and most widely abundant molecule, that is water or H2O. Fine. So another thing is that this water molecule, if you look at our earth, it is available in unlimited amount. No, it's not right thing, not unlimited. Everything is limited on earth, but this is widely available, huge amount, because our oceans are filled with water. But there is a problem, because oceans are filled with salty water. So that's another issue which will come later. Now this, if we can purify this ocean water into clean water by the process like reverse osmosis, the technology we used water purifier like Kent. So this reverse osmosis technology, if we use, and if you can produce drinkable water, or further one step, if you can use further more pure water, then that could be utilized for electrolysis to produce pure hydrogen. Not only that, even if we store the rainwater, which is the purest from almost, so that can also be a potential for preparation of hydrogen. Okay, that could be used as a fuel. And not, so that's the one thing. Another thing is the -1 oxidation state, and the best example for -1 oxidation state is the methane molecule. Okay, hydrogen is relatively more electronegative than carbon, so you can consider that, so you can consider that this is actually -1 oxidation state. But this methane is also widely available. Student, you may consider that, sir, in natural gas methane is a main component, but petroleum could be finished. But there is another very important source of methane, that is methane clathrates. I shall discuss in a dedicated video future. Methane clathrate means it's a gas hydrate. So if we combine the methane clathrate present in the earth, that its amount is more compared to the overall petroleum based hydrocarbon presently discovered. So it's a huge amount of this methane clathrate sources are there. So both are available. One is water, another is methane. By the way, you remember this water is more stable compared to methane, which will come after some time about the consequence of this concept. So the question is, which bond is stronger between OH and CH? Means if you look at the two main sources, that is water versus methane. If you look at the reactivity point of view, this water molecule is more polar because the electronegativity difference between hydrogen and oxygen. That's why this is delta plus and oxygen is delta minus. But this methane molecule is actually very less polar. So since the carbon hydrogen bond is very less polar, that's why it is very difficult to chemically functionalize this methane into, for example, the best reaction you may consider our desired one, that is methanol. You may consider that only one oxygen is inserted in between one carbon hydrogen bond. Actually methane is a gas and this is liquid near about 64 to 65 degree boiling points. You may consider closer like petrol. So that is the most desired reaction, but right now, till now, we didn't reach the technological achievement such that we can produce methanol from methane on a commercial scale. So this is our target. So right now what they do, they follow an alternate pathway. First of all, they convert it into CO and then methanol. We will come later on. So this is actually, this hydro water is more reactive than hydrocarbon like methane, but energy store point of view, methane store relatively more energy because water is more stable. So selective CH functionalization is difficult here. Now, so methods for preparation of hydrogen, if we consider from CH bond, just as some time before I told that this is relatively more reactive. Question, why this is? Because of one reaction, that is, if you look at this methane plus water, if they react high temperature 100 to 1400 degrees centigrade, it produces this carbon monoxide and this hydrogen, and this carbon monoxide, we know it's not an ultimately stable molecule. So this carbon monoxide is further utilized for water gas shift reaction to get extra hydrogen. How? By reacting this carbon monoxide and water, it produces carbon dioxide. Remember student, carbon dioxide is one of the very stable molecule. It is thermodynamically stable and kinetically relatively inert, and along with that it produces one molecule of extra hydrogen. So from one molecule of methane, if we focus, how many molecules of this hydrogen we are getting here? 3 molecule, here 1 molecule, so 4 molecule. And this, so that's why this reaction is very interesting. Now, if you read this thing, hydrogen producing usually natural gas. Actually, remember, natural gas consisting mainly methane, and it's actually a fossil fuel based, and there is another source, that is methane clathrates, but which is not commercially utilized till now. So which involves the removal of hydrogen from hydrocarbon at a very high temperature. And remember that around 48% of hydrogen production is coming from steam remorphing. Steam remorphing means two-step, and commercial bulk hydrogen is usually produced by steam remorphing of natural gas. Okay, it's a petroleum based source, and this method is also known as Bosch process. Please remember what is named as Bosch process. In exam it may ask. So in this case, what is the negative point of this Bosch process? Negative point is that this ultimate CO2 emission. We know such kind of CO2 emission is responsible for global warming. We know that day by day we are accumulating excess CO2 in the atmosphere. Consequently, the average global temperatures are increasing. Consequently, it bringing about many natural calamities. So that is the main concern. But what could be the ideal thing or best solution in this context? If we are able to achieve a technology based on we can break this methane into carbon and 2 molecules of hydrogen, and we will store this carbon in some places, and that could be the best, but till now this technology is not developed. Now, what is the greenest method? Actually, this is the greenest method for preparation of hydrogen from OH bond. And what is the source of OH bond? Obviously water. Huge amount of water we have in our planet. Now, in this electrolysis, what is a simple method producing hydrogen? Actually, pure water is not conducting because it's a covalent molecule, but in acidic or alkaline solution or salt solution, conductive because of the ions. And what happens if we provide a DC potential? Okay, DC potential, then it promotes, it allows the protons to migrate towards negative charge electron, because protons, remember, H plus. So where it will go? Where the electron is reached, that is cathode, and consequently it will take one electron, form one H dot, and another thing, it will combine another H dot, and it will produce the hydrogen gas, and this hydrogen gas will come out. Similarly, in the anode part, you can see the evolution of oxygen, because in anode is positively charged, so OH minus go and remove its electron density, and ultimately it will become converted into water, so oxygen. So in this reaction we are not only getting hydrogen, along with that we are getting oxygen. And remember, this hydrogen and oxygen gas, if we combine in a fuel cell, and we can get huge amount of energy, means you may consider that it could be a future fuel, okay, this combination. But along with this mixture of this hydrogen and oxygen is very dangerous, and that happens if we do direct or traditional electrolysis of water, and this problem could be solved by another process, that is membrane based system. What they do, you can see this membrane here. So this membrane allows the flow of proton only, so consequently proton can pass through membrane but gas can't. So in the anode reaction, means anode part, you will get pure oxygen, and in the cathode part you will get pure hydrogen. So whenever you need, based on your wish, you can react both of them and produce energy, and in this case it will produce water which is not harmful like carbon dioxide. Okay, so that's why if you look at this situation, the membrane based system are better than traditional water system, because it allows the only the H plus movement, and no mixing of gas happens between hydrogen and oxygen, and it's relatively, means electrodes are safe for side reaction here, and efficiency is greater than in membrane based system. Okay, so this is the overall thing. Now, so we have understood the green way for producing hydrogen, but there is some problem. First problem is over potential for electrolysis of hydrogen production. Okay, so another few points we should remember while we want to prepare this carbon neutral method for future fuel like hydrogen generation. What you will say instantly that, sir, we will do electrolysis. If we need some more energy, okay, well, fine, give. But we can produce hydrogen in this way. Global warming will not happen. But the biggest issue is that the electricity needed for water splitting should come from carbon neutral sources like sunlight, hydropower, tidal energy, wind energy, geothermal, nuclear, biomass, etc. But remember, student, majority of power or electricity coming at present is from fossil fuel based. Even very few days before, you have heard a news that because of coal crisis, many countries like European Union, India or China are going to face a huge amount of blackout. So this is the proof that how much we are dependent right now also on fossil fuel based source. So that's why such kind of water splitting, means water splitting to produce hydrogen, is not, first of all, beneficial from commercial point of view. Second, it is not profitable from environmental point of view. So it will be useful when we can produce this thing from electricity which is produced from renewable sources. Now let me discuss a little bit. So renewable sources means, if you see sunlight, so sunlight is available huge amount in the day, but in night it is not available. So what we can do, we can produce huge amount of electricity in the daytime, and that electricity should be utilized for the preparation of both hydrogen and oxygen, and we can store this, and we can, in the night time, using a fuel cell, we can produce electricity back to this. Means you can consider it's a energy storage, sunlight's energy storage through a chemical transformation. So that's the thing. Not only sunlight, excess means when there is a huge amount of water, means airflow like heavy wind or some other issue. So that time that excess energy could be converted into this hydrogen and oxygen, and later on it will be utilized. So that is the best from energy waste point of view. Now, so in this way we can produce what you have told using this method that time. But the most important thing is that is a carbon neutral method is needed for executing everything. And in this context, based on my personal opinion, there are very few resources, very few reliable sources. One is sunlight, because closer to tropic, if we say huge amount of sunlight available, and if we are able to install solar panels properly, so after few years we can see a huge amount of benefit, because initially production of solar panel also induces some CO2 emission, so that's why after few years it will be profitable. Second point, if we install huge amount of solar panels, so excess energy will be there, so we can convert this into water and oxygen and utilize later on. Second thing, we need to be dependent on nuclear. We need to be very much careful, and we need to be we need to trust on technology such that, because nuclear is the option. Night time, what will you do? Because right now if we have many renewable sources energy production, fine, but when there is a crisis or imbalance for production of power, then what we do right now, we use coal power plant. So those are like a backup thing. So if we want to completely remove the coal, then we need to be very much dependent on nuclear, and better technology for nuclear power generation will be needed in future. Now, so this is we understood. So in conclusion, what we have learned today, hydrogen is the lightest, cleanest and highest energy abundant fuel, and it is the most energy rich. Currently H2 could be generated from both natural gas and electrolysis, but natural gas is the biggest source nowadays. Hydrogen should be generated from carbon neutral process. This actually we need green hydrogen, and that is needed in order to fight against global warming and climate change. And remember, this hydrogen is environment friendly, cheap, and if we can add carbon neutral process, it will encourage us to develop this fuel cell technology further on a commercial basis. For not only power generation, for electricity generation, we can use this fuel cell for our transport, like in car, because transport industry releases huge amount of CO2 annually, and additionally we are dependent on fossil fuel for this purpose. But if we develop this fuel cell technology properly, then we can use it in car also. So that's the overall discussion. Thanks for watching, and please remember that our target should make environment better place